After we learn the implicit differentiation, and we're going to learn how to take the second degree of the derivative. The second derivative sometimes it has to, well, we have to find it like a kind of implicitly because sometimes it's not that obvious. You might have to have the y involved. I'm going to work on two examples, and this part should be kind of short. Okay, the first one looks like this: x squared plus y squared equals 25. And you remember that, right? So I will ask you to find d square y over dx squared. So that's a second degree of freedom. To find the second degree of a derivative, if we need to find the second degree, we need to find the first degree first. So I'm going to do the first derivative, x squared plus y squared equals d dx 25. Okay, so this one derivative, I got a 2x, and this one by chain rule, I got a 2y, then dy over dx, right? And then the right side is 0. So I get a dy over dx equals, see, I subtracted 2x, then divided by 2y, and then I get rid of the 2, so I get a negative x over y. So that's the first derivative. And then in order to find the second derivative, I have to take the derivative for this again with respect to x. So my d squared y over dx squared, that means the second degree of freedom, that will be d dx, and then I'm going to put negative x over y. So I will take a derivative of this with respect to x again. So that gives you the second derivative. So that would be, okay, so you can leave this x on top, then it becomes this f over g prime is f prime g minus f g prime over g squared. I keep writing this I want to make sure that you're familiar with that. Okay, so the denominator is y squared, and then the numerator, because I can treat it at negative x, is f, so that's negative 1 times y, okay, then minus my f is negative x, and then y is derivative dy over dx. Okay, and did you notice that I have a dy over dx, but actually I know what is that? So that's the tricky part when you work on the second derivative. You are going to have dy over dx, but you already know what is the first derivative, so you just need to plug in. Okay, so that is y squared, and the top is negative y plus x times dy over dx, which is negative x over y. Okay, so that is, let me put this, I still have a y squared. And then I multiply by y everywhere, so I get a y cubed. And then here I get a negative y squared because I multiply by y, and then negative x squared. But the thing is, we know x squared plus y squared is 25. So negative x squared, negative y squared is just negative 25. So my answer is negative 25 over y cubed. It doesn't really look so obvious at the very beginning, but you do this step by step, you get the answer. Isn't it interesting? Yeah. Okay, so let me, because I don't think we have a lot of examples there, but I will find some example for you here. Okay, so I'm going to work on another example, okay? This. I hope I have enough space. I might need more paper. Yeah. All right. Now, if you have y squared equals x squared plus 2x, okay. Again, I ask you to find d squared y over dx squared. Find the second derivative. So let's find the first derivative. Okay, so did you see that I keep writing this? Okay. Equals d dx x squared plus 2x. Okay, so the first part, the left side is 2y dy dx, and the right side is 2x plus 2. Okay, so well, I have a 2 everywhere, so and I just forget about 2. I will cross out 2 later, and then I divide it by y, so I get a dy over dx equals x plus 1 over y. Sounds good, isn't it? That's the first derivative. If I take the derivative of this with respect to x, so I get a d square y over dx squared equals d dx, this x plus 1 over y. Again, this is, we're going to use the quotient rule, so that's going to be y squared. And then the numerator prime, which numerator derivative is 1 times y minus, then x plus 1, and then this is dy over dx. That's the derivative of the denominator. Okay, so that becomes, I have a y squared, okay, and here I have a y minus x plus 1, but don't forget that you already know what is dy over dx. Remember that you substitute, okay, because you have the first degree derivative, x plus 1 over y. All right, now then you are going to multiply by y on both numerator and denominator. So you get a y squared minus x plus 1 squared, and the denominator you have a y cubed. That's your answer. So what do you think? It's not too bad, right? So I think that's everything I need to teach you, I think. To find the second derivative, what you need to do is to find the first derivative, and then you take a derivative of that first derivative with respect to x. But in the middle, you might have to substitute your dy over dx there in order to find your final answer. Okay, so I think that's about it. If you like, I can do one more exercise because I think we have a lot of time. So I'm going to do one more exercise for you. Let me see. Oh, let's do this. Y cube. Okay, how about this? Y cube plus 2y. That equals 4x squared plus 3x. This just shows you the relationship, and I'm asking you what is the second derivative. All right, now we're going to take the first derivative. Okay, I think this is the last example, so I'm going to skip a lot of steps. I just need to talk about it, and then to see whether you can follow me. Okay, is that okay? So I will take the first derivative. That would be 3y squared dy over dx plus 2 dy over dx, okay? Then that equals, okay, so that would be 8x plus 3. I hope you see what I'm doing here. All right, then I'm going to factor this dy over dx. I will have a 3y squared plus 2, and I'm going to divide it by that both sides. So I get my first degree derivative. That should be 8x plus 3 over 3y squared plus 2. That sounds good right now. Okay, so I'm going to take the derivative of this again with respect to x. Quotient rule. So d squared y over dx squared. Quotient rule. The denominator square. Okay. Numerator prime. I get 8. Copy the denominator. Okay. Minus. I write down the numerator, and then I take the derivative with respect to x for the denominator. So I get a 6y dy over dx, and then plus 0. Okay, so did you see that I have a dy over dx, and which is here is already given? Yeah, it's just a lot of writing. So it's 8 times 3y squared plus 2 minus, okay, I write a 6y 8x plus 3, that's this part. And then I'm going to write multiplied by 8x plus 3, okay, over 3y squared plus 2, 3y squared plus 2 squared. And then I bring this down, or I multiply by 3y plus 2, both numerator and denominator. So the numerator I have 8, 3y squared plus 2 squared. The denominator is 3y squared plus 2 cubed. And then the numerator I get minus 6y times 8x plus 3 squared. Okay. It looks very, very long, but it's not really bad because you still do that step by step. You can get it. I think that's all we need to know to find the second derivative of a implicit or of a like implicit uh, expression. Okay, that's all for this.